Okay, illustrative math, unit 2, lesson 18 is called Graphs of Rational Functions, part 2. All right, our goal today is I can identify a horizontal asymptote from a graph or a function. So we've talked about vertical asymptotes. Horizontal asymptotes are the opposite direction. So instead of going up and down, we're going left to right, okay, just like that. So the line y equals c is a horizontal asymptote of the function if the outputs of the function get closer and closer to c as the inputs get larger and larger. So as x gets bigger and bigger, your y values start to level off, okay? And it can go either direction, okay? Like if my graph looked like this, it can start to level off at c as x gets bigger and bigger. So as I move right, my y's are leveling off at some horizontal line, okay? All right, so I have this Bobo, Bowden, eats DC down here. So if I have a rational function, Bobo stands for bigger on bottom, y equals 0. Okay, so the bigger on bottom 0. And when I say bigger, we're talking about the degree of the top and the bottom. Okay, so let me give you, and then let's go to the next one. Bowden, bigger on top is none. And then exponents are the same, divide coefficients. Okay, so I'm going to give you a couple of examples here so you can see what the horizontal asymptote is. So if I have f of x equals, I don't know, x plus 2 over x squared plus 3x minus 4. If that's my rational function, you look here, the degree of the top is 1 because it's the highest power. Degree of the bottom is 2. So the degree of the numerator equals 1. The degree of the denominator equals 2. So that'd be a bigger on bottom. So the horizontal asymptote, and I'll just abbreviate it with HA, would be y equals 0. Okay? Now bigger on top, none. So if I just had a higher power up top. So if I just switch these two, so it's still a rational function. So I'm going to put the squared polynomial in the numerator and the first power in the denominator. So degree of the numerator is 2, whereas the degree of the denominator is 1. So that'd be a bigger on top. So we have no horizontal asymptote. And then here, exponents are the same, divide coefficients. So if I have like 3x squared plus 2x minus 1 over x squared minus 4. So the degree of the numerator is 2. Degree of the denominator is 2 as well. So we divide the lead coefficient. So there'd be a 1 here and a 3 right there. So, and make sure you put the y equals, because horizontal lines are always y equals. So y equals 3 over 1, or just y equals 3 would be my horizontal asymptote. Okay, so that's how we're going to do it. Now I will also say here, let me move on here, let me show you here. Sometimes they do stuff like this where they give you like, I don't know, g of x equals 3 over x plus 2. You could think of this two ways. You could just not pretend that this isn't here, this plus 2 for now, and just look at the 3 over x. So that would be a bigger on bottom. Bigger on bottom. So I go up to my Bobo, bigger on bottom is y equals 0. So if this was my function, if I didn't have this here, I'm going to cover that up for a second. this would have a horizontal asymptote at y equals 0. But then since I have the plus 2 here, so I'm going to erase this and rewrite it. It's like everything's going to move up 2. So my horizontal asymptote would now be y equals 2. Okay. What you could also do is, if that's confusing to you, you could do this, 3 over x plus 2. If I put this over 1, I would need a common denominator to add fractions, so I'd multiply by x over x. So now I get 3 plus 2x. I'll put the 2x in the front. So this would be my function, g of x. So now it turns into a each DC. Exponents are the same. Right here, divide coefficients. So I do the 2 over the 1. So it'd be 2 over 1 equals y, which would be y equals 2. So either way would work. I usually just think of this as 0, but then since I'm adding 2 on, everything moves up 2. Everything's 2 greater, so my horizontal asymptote will move up 2. All right, so here's our warm-up. Decide if each of these equations is true or false for x values that do not result in a denominator of 0. So we're just going to plug in some numbers here. So let's just try x equals 1. If I plug in 1 here, 1 plus 7 over 1, is that equal to 1 plus 7 over 1? Well, this would be 8 over 1 is 8. This would be 1 plus 7. That works. Okay, let's try a different number. Let's try x equals 2. So this would be 2 plus 7 over 2. Is that equal to 1 plus 7 over 2? This would be 9 over 2. This would be 2 over 2. So if I got a common denominator, it'd be 2 over 2 plus 7 over 2. That would give me also 9 over 2. So it looks like this one is a yes. Now, I'm not sure. I didn't prove it, but I have a strong hunch because it worked for at least 2 of them. So this one here, I can't plug in -7. Just like here, I could not plug in 0 because 0 would give me a 0 in the denominator. I can't plug in -7, but I could plug in any other number. So let's plug in, I don't know, 1. Let's do the same. I always like to pick small numbers. I think it's easier. 1 over 1 plus 7. Is that equal to 1 plus 1 over 7? This would be 1 over 8. That would not be equal to, that's 8 over 7. That's not equal. So this would, once I find one that does not work, that would be a no. Okay. I have a counterexample here. It does not work for x equals 1. Here, I tried it for 2 different numbers, so I have a strong hunch that it does work. All right, so here's my function c. Let c be the function that gives the average cost per book, c of x in dollars, when using an online store to print x copies of a self-published paperback book. So here's my graph. So it looks like my horizontal asymptote is y equals 4. Let's just answer the questions first, though. What is the approximate cost per book when 50 books are printed, 100 books are printed? So all I got to do is find C of 50. So I plug in 50. So let's see here. This would equal 320 over 50. And my calculator, 320 over 50 is 6.4. All right, so there's C of 50. C of 100. Well, that would be 120 plus 4 times 100 over 100. 520 over 100. 5.2. Okay, so C of 100 is 5.2. All right, the author plans to charge $8 per book. about how many should be printed to make a profit. I guess, you know what, going back up here, I guess maybe I should say, since it's cost, should probably make it 640 and 520. That might be better. So if they plan to charge $8 a book, how many should be printed to make a profit? So as I look here, I'm going to basically plug in 8 for C of X. And I'm going to multiply each side by X. 8X equals 120 plus 4X. If I minus 4X from both sides, I get 4X equals 120. So X equals 30. So 30 will be your break-even point. So how many should be printed to make a profit? I would say more than 30. Okay? Because 30, think about this. If I plug in 30 here for X, I'm going to get 8. Okay? 120 plus 4 times 30 is 240. Divided by 30, I get 8 exactly, which is what I found. So I need to make a profit, so I need to have more than 30. Okay? What is the value of C of X when X equals 1/2? How does this relate to the context? So C of 1/2, I'm going to use 0.5 just because it'll be easier to plug in. 120 plus 4 times 0.5 divided by 0.5, I get equals 244. So that would mean, so remember, X is the number of total books printed if you look right here. So I would say to print half a book, it would cost $244. Now, in terms of the context, I would say it doesn't really make sense, okay, because you're not going to print half a book. Okay. All right, so here's 4 graphs that are rational functions. Match each function with its graphical representation. So if I go back to my Bobo, Boatin, eats DC, all right, we can kind of figure out our asymptotes here. Now, the ones that it won't work for is when we have more than one term, if it's not all one fraction. So you could think of like this one here as y equals 0, but then you move down 1. So this one's y equals -1. Same thing here. This is y equals 0, but then I move down 4. So this is going to be y equals -4. Now, this one's all one fraction. So it looks like my exponents are the same. So if I divide the highest power term, it'd be 4 over 1 in front of there. So that would be y equals 4. Again, here, exponents are the same. Degree of 1, degree of 1. So it's leading coefficient 1 over 1. If I go over here, this one is exponents are the same, 1, 1. So divide your coefficients, -4 over 1. This one here, again, exponents are the same, degree of 1, degree of 1. So it's -1 over 1, which would be -1. This one here, this is 0. 4 over x is y equals 0. But then since I add 1 on, it goes up 1. So this is y equals 1. And this is 0 here, 1 over x. But then since I add 4, it goes up 4. Okay? So I can kind of match them up right now. So graph B is going to go with, this is y equals -4. That's going to go with E and B. This is y equals 4. So that's going to go with graph C and H. This is y equals 1. So that's going to be graph D and G. And then this is y equals -1. So that's going to be A and F. Now, if you wanted to do the common denominator for these ones, like let's take a look at G. 1 plus 4 over x. If I multiplied this by x over x, I would get x plus 4 all over x. Then I can go to my Bo needs DC. My exponents are the same. If you look here, exponent of 1, exponent of 1. So I divide the coefficients. So it's 1 over 1, y equals 1, which is what I said there. Okay. Same thing here. If I wanted to do this one here, I'll come up here. So this would be 1 over x plus 4. This is over 1, so I need to multiply this by x over x. So I get 1 plus 4x over x. So exponents are the same. Both have a power of 1. And when I say exponents, we're talking about the highest power. So leading coefficient's 4, leading coefficient's 1. So it's y equals 4 over 1, which is 4. Okay? Where do you see the horizontal asymptotes? I kind of already answered that with matching the graphs. All right, so identify the horizontal asymptote of each function. So this is all one fraction, so I can do my Bo needs DC. Highest power is 1, highest power is 1. So coefficient, lead coefficient over lead coefficient, this is y equals 7. Again, here exponent 1, highest power is 1, divide coefficients, so it's y equals 7 over 2. And again, here, same thing, divide. So it's all of these are in each DC. So it's y equals 7 over 0.5. Now, I don't like to have a fraction with a decimal, so I'm going to divide it, and that's going to actually equal 14. Okay, so those are my 3 horizontal asymptotes. What are 2 ways you could change a single number so it has a horizontal asymptote of 35? Well, all you got to do is add a number on here. So if I'm already at 7, I need to move up 28 more. So what I could do for this function here is, let me just erase it here. Or I guess I could come over here. I could rewrite it as f of x equals 7x plus 2 over x. And then I could just put plus 28. Because if I was already at 7, I need to move up 28. This is 7 over 2 is 3.5. So I'd have to go up 31.5. So I'm going to take the same function. And I'm going to say, okay, 35 minus 3.5 is 31.5. So I'm just going to add the 31.5 to shift it up to 35. And this one was at 14, so I think I need to go up 21. So it's going to be the same function here. And that'll move it up. All right, cool. I can identify a horizontal asymptote from a graph or function. Hopefully that Bo needs DC helps you guys. It's not something that our book uses, but it's a trick that I've been using for a long time as a teacher, and I think it really clarifies the horizontal asymptotes a lot. All right. Oh, I know I had one more. All right. So cool down. Average cost of printing X copies of a self-published paperback book with company A is given by this function. Average cost for printing copies of paperback with B is given by this function. Which company would you recommend to an author who wants to print 100 books? So I'm just going to plug in the 100 for X. So I'm going to find C of 100. So this is going to be 120 plus 4 times 100 divided by 100. So that's going to give me 520 per book. And then if I try the other company, D of 100, let's see here. I get D of 100 equals 5.1, we'll call it 13. So obviously I would recommend company B, because company B is the D of X. All right, and it's cheaper. All right, which company would you recommend to an author who thinks their book will be a bestseller and needs to print thousands of books? How could you rewrite the equations to make the choices clear? So as X gets, excuse me, as X gets bigger and bigger, it's probably going to level off here. So you could just kind of figure out your asymptotes. We really don't need to rewrite the equation. So for company A, your asymptote, let's see, divide coefficients because the exponents are the same, y equals 4. So the more books you pick, the more your function is leveling off here at 4. Okay, that's your horizontal asymptote right there at 4. It's getting closer and closer to 4 because I did an each DC divided coefficients because the exponents are the same. For company B, let's see, again, exponents are the same, divide coefficients. What do I get here? So 10 over 2, y equals 10 over 2 is $5. So that would look, kind of like this, but it's leveling off at 5 right there. So as X gets bigger and bigger, we're talking thousands. This is going to level off at 5. This is going to level off at 4. I would definitely recommend company A as my answer because it's going to get closer and closer to 4, which will be cheaper in the long run. So your graph would look something like this, like company A is going to be like that. Now company B would be up here. So because in this part here, B was below A. So it'd be like, if this was 100, this is my axis here, like 100, 0 is like way over here somewhere. So B is below A somewhere there, okay? But eventually A is going to level off at 4 and B is going to level off. I'm a little off on that. B is going to level off at 5, okay? Kind of like here, 4 and 5. So obviously long-term A would be better because you're going to go lower. But at that given moment at 100, B is below. So anyways, hope you enjoyed this lesson. Thank you for watching.